Hello everyone. In an attempt to make lots of mistakes, not really on purpose, but that's how we learn, right? I'm just going to think out loud here as a thought experiment. How does that sound? Shall we share a thought experiment together? What's this? My spelling and grammar will be highly flawed. But what's important is that we understand the basic ideas of what we're trying to say here. This is going to be the controller. And in this instance, let me think about this now. This is a very good question. Is it a brushed DC controller, or is it a brushless controller? So if it's a brushless, the ones I think of usually have 3 wires coming out, right? For brushless. Brushless controller, and then a brushed controller. Tends to have 2 wires that come out, right? And these are the wires here. Now, that's going to go to a motor, but here's the thought. This is a thought experiment, okay? First of all, how are you today? Are you having a good day? I hope you're having a great day, a very creative day. Another day of redefining what we think of as being possible, right? Pure potential, pure possibility. These controllers can be powered by lead acid batteries or any battery, any chemistry battery, right? They can be powered by lithium batteries powering these controllers. These give power to the motor. What I would like to do is, and this is what I'm thinking about, and I thought while I was thinking this through, I would share it with you. What's coming through these wires? John Bedini talked about pulse width modulation a lot. Brushed controller. The brushed controllers I have are pulse width modulated, PWM. The brushless controllers I have I don't know if that would be I don't think that's pulse width modulated. And I think they're, yeah, I don't know. I don't actually have the answer to that. But here's the experiment. That's something to look into, right? But John Bedini often talked about pulse width modulation as being very important. So if we look at this one, brushed, one's positive, one's negative, right? Either one. And we'll call this a PWM for pulse width modulation, right? And this is a controller as well. It's a motor controller. Brushed motor controller. Okay, now I'm mixing handwriting and regular writing. Okay, so what's important is what's happening in these wires here. So if we have a motor This is some experiments that I want to do. Let's say we have a motor, right? Okay, and the motor's, this has wires, right? This is not perfect, but it's just an idea, to get the idea, okay? Okay. What I'd like to try is, now here's a thought I was having. One of my thoughts was, if I could connect to that wire, see this wire right here? Now I'm not sure how to think about this, but let's say I connect, let's say we leave that wire connected, right? But I connect to that wire, let's say I connect to it here and here, and then that goes into a full wave bridge rectifier. So we're going to be getting pulses in here. First of all, what's coming through here? Is this sound waves? Gerard Morin, if I understood correctly, said that our motors are powered by sound waves. So are these sound waves coming through here? I don't know. I don't know what's coming through here. But this is just a thought. Okay, whether this is sound waves or not, I'm just saying that because sound waves are very interesting. And my understanding is the universe is powered by sound waves, literally. So what does that mean? Does that mean that subatomic particles are powered by sound waves? Can we create material? Can we create matter from pure energy with sound waves? That's a question. What happens with the introduction of sound waves? There's a significance to sound waves, okay? And don't forget that Donald Lee Smith refers to every electric motor as an anti-gravity drive or a gravity drive. It's a gravity drive. So who's interested in anti-gravity or gravity neutralization or whatever you want to call it? There's a lot of different names. We're going into a full wave bridge rectifier here. And then, so one of these are going to be a plus and one's going to be a minus, right? This is our pulse signal coming in here. And then one's a plus and one's a minus. Then we take this and power, from what I've read, if I understand correctly, because I might not be doing this right? That's why I have to just try different things. But if I understood correctly, and I may not have, we can power LEDs. Well, actually, we want to do that over here. That's how it was recommended. I'm just thinking, what happens if we get close into the motor in here? We just get right into the motor. Now, is there room to do all this? Probably not. That's why I'm moving it over to this. That's why I want to do it here. But, you know, I'm just doing, this is a thought experiment, so we could do anything, right? Einstein, right? Thought experiments. Einstein doing thought experiments, right? So I'm thinking about thought experiments, and I thought I would just document some of the process of sharing with myself and with you, of the process of thinking through something. A full wave bridge rectifier converts pulsing AC into a pulsing DC, right? If we connected here and here on a wire, on any of these wires, right? Or all three of them even. But to begin, just pick one. And then this went to a full wave bridge rectifier, right? That's our pulse input. And then we get a plus and a minus out, right? So one of these will be plus and one will be a minus. Or that'll be plus and that'll be minus, one or the other. And now, from what I've read, my research and study indicate, if I understood correctly, and how far apart does it have to be? I don't know. I don't know if it has to be far at all. We could try different lengths apart. We could try, 3 inches, 4 inches, 5 inches apart, or a lot more. Like we could try many feet apart, like connect right where it comes out here and then where it goes to the motor. That could be 3 feet away. So both of those tests would be interesting. And from what my research and study indicate that we can power LEDs with this without interfering, without increasing the amp draw from the battery to get the same work done with the motor. So this might be an efficient way to run LEDs. Now, if you do this, and I'm going to do this knowing that I might burn out the LEDs, I'm not telling you to do this. I'm not saying do this. This is a thought experiment, and I'm planning to experiment with this very careful, under very careful conditions, wearing full shielding, full gear. We don't know what's going to happen, right? My research and study is pointing me into this direction, so I'm looking at it. I'm seeing what's here, right? What if we connected? Now, this is just my own thoughts, but my research and study indicate that we want to stay on the same wire. But what happens if we go across two different wires, right? I don't know. That's more testing. But I should begin, my thoughts are I should begin where the research and study is pointing the direction it's pointing me to, which is the same wire at two different points, into a full wave bridge rectifier, the output powering LEDs, and see what it does, right? Now, if needed, I guess we could put a capacitor there, and maybe the capacitor would determine our voltage. So if we don't want to put too much voltage into, well, I guess voltage and current possibly, but if we don't want to put too much voltage and too much power into the LEDs, maybe connecting the output here, the positive and negative output, into a capacitor. Now, there's a lot of different kinds of capacitors, and I wouldn't know which one to use, so that would also have to be considered. But different capacitors can be experimented with, but again, we never want to put too much power into a capacitor, because what can happen? It can become damaged and cause harm, right? Because it can pop. So we want to make sure that the test is conducted in a box or some kind of sealed container so no one's getting hurt, right? Wearing safety glasses and full gear that covers every part of our body. So, and then having no one around at all, and nothing that can burn or have a fire extinguisher nearby. We have to be very careful when doing tests, right? But this is an idea here. Now, also, what would happen if we connected these outputs to a battery? Let's say the same battery, for example, with lithium, right? My research and study indicate that if we try to charge a lead acid battery, that it would be too much power for it, if I understand correctly, and it would cause it to dry out, right? I think that's, if I recall correctly, what is happening there in my research and study. Now, what if we use something like lithium, though? We'll also have to be very careful not to overcharge and not to damage the cell, and also to not allow the temperature to increase too much. So we have to watch those parameters, right? Temperature and total voltage of the lithium battery, not letting it go over, right? Because as we're accelerating here with our power, what's going to happen here? What's happening here when we're putting more power to the motor? What's this doing, right? So this is all just thought experiments, and it's material for reference for me of experiments I'd like to do and see what happens. Okay, now this same test can be conducted over here as well, right? This is pulse width modulation. I don't know what this is called at the moment, but that would not be hard to look up and find out when you're talking about, this might be referred to as three-phase, right? 3 wires powering a brushless motor, right? This is powering a brushed motor, pulse width modulation. Now, John Bedini spoke highly of pulse width modulation, and he said, this is very important. What's it important for? Why? Well, look at his work. Look at John Bedini's work, his research, right? There's a lot of books that he has shared his thoughts in his experiments. Anyway, everyone, so this is the beginning. So here, what happens if I do this, right? We have the input going, and then we have a plus and a minus, and then we send this to LEDs. Now, if it doesn't take more power from the system, from my battery that's powering the controllers, this is could be an efficient way to run LEDs, right? Does this have to be connected here, or here and here, or here and here, or here and here? Where is it most efficient? And then also, again, what happens if we connect the outputs to a battery, right? And different chemistry batteries, this is just a thought. I'm not saying to do this. I'm just sharing thoughts as thought experiments, okay? Because we have to be very, very careful with batteries. especially with lithium, because we cannot overcharge a lithium, ever. So, but if we study G batteries, I think they're sending high pulses of really high voltage, if I understood correctly. It looks like it could be really super high potential going into regular lithium batteries, but they're making sure they don't overcharge, right? So is it okay to put a higher voltage into a lithium battery until that battery reaches fully charged, right? Pulsing a lot of power into a battery. Pulse, 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 right? Not just continuous force, right? That's what we're learning. Is force is not how nature works. Not forcing. Pulsing. Have a great day, everyone. This is just the beginning.